Welcome to Ask and Learn.
All right, so for this one, we are given that an is equal to negative 3 times an minus 1 minus 3 an minus 2, and then minus an minus 3. And so n would need to be greater than or equal to 3 in order for this to make any sense. And so we'll start with the roots characteristic equation. So we'll let an be equal to r cubed. And so an minus 1 is going to be r squared. An minus 2 will be r. And then the an minus 3 will just be equal to 1. And so if we substitute these values into the equation given, we end up with r cubed minus is equal to negative 3r squared minus 3r minus 1. And when we move everything over to the left-hand side, we get r cubed plus 3r squared plus 3r plus 1 is equal to 0. And then we factor, and when we factor this, we get r plus 1 cubed is equal to 0. So this means that our roots are negative 1, but with multiplicity 3, right? So 3 times. Okay, so we'll use those roots to build a solution to our recurrence relation, and that solution will be of the form an is equal to alpha 1 times negative 1 to the n plus alpha 2 times negative 1 to the n plus alpha 3. And this should be, due to the multiplicity, this will actually be times n. Okay, then alpha 3 times negative 1 to the n, but then multiplied by n squared. Okay, so we'll use our initial conditions to solve for this. So we know that a naught is equal to 5. If we put a 0 in across the board, we end up with 5 is equal to alpha 1. And then we know that a1, which is equal to negative 9, if we put a 1 in for n across this equation, we get negative alpha 1 minus alpha 2 and minus alpha 3. And our last one, a2, that was given to us as 15. If we put a 2 in for n in this top black equation, we end up with 15 is equal to alpha 1 plus 2 alpha 2 plus 4 alpha 3. Okay, so we're going to put the fact that alpha 1 is equal to 5 into these other two equations. Okay, so what that's going to give us is negative 9 is equal to negative 5 minus alpha 2 minus alpha 3. Okay, which really says that negative 4 is equal to negative alpha 2 minus alpha 3. And if we do the same thing with the second equation, it comes out to 10 is equal to 2 times alpha 2 plus 4 times alpha 3. And so we're going to multiply the top equation by 2. And when we do that, we get that 8 negative 8 is equal to negative 2 times alpha 2 minus 2 times alpha 3. And so now we can just add these two equations together to get that 2 is equal to 2 alpha 3, which implies that alpha 3 is equal to 1. Right, and so now we can put this back into any of the above equations. And so let's just pick the first one, which would mean negative 8 is equal to negative 2 alpha 2 minus 2. So I could add 2 to both sides to get negative 6 is negative 2 alpha 2. So this would imply that alpha 2 is equal to 3. Excellent. So we have our alpha 1, alpha 2, and alpha 3 figured out. So the only thing left to do is put it into this equation, right? And so we have an alpha 1 of 5. We had an alpha 2 that is equal to 3. Make that green. And we have a alpha 3 that is equal to 1. Okay, so our solution then is that an is equal to 5 times negative 1 to the n plus 3n times negative 1 to the n plus n squared times negative 1 to the n.